Lesson 3.7, Graphing Equations of Lines. In this video, you will learn how to find the slope of a line and to write different forms of equations for lines. Some of this you did in Algebra 1. Some of it will be review, some of it may be new. Example 1. In this example, you will find the slope of several given lines graphed on the coordinate plane. Here we have the x and y axes. And we have line A, line B, line C, and line D. They've also provided ordered pairs for some of the points on the lines. Find the slope of each indicated line from the graph provided. A. What is the slope of line B? Recall that the slope formula is the difference of the y coordinates between the 2 points and a ratio over the difference of the x2 coordinates. The 2x coordinates. Rise over run. The change in y over the change in x. And so starting with this first one, line B, locating line B, we're provided 2 points on the line. One at -1, 2, one at 4, -2. If I'll let this be my first point, this be my second point, I can call -1 my first x coordinate and 2 my first y coordinate. I can call 4 my second x coordinate and -2 my second y coordinate. So the slope of line B is equal to y2 is -2 minus y1, which is +2, over, back over here to the x2, be 4 minus -1. -2 minus 2 is -4. 4 minus -1 is 4 plus 1, which is 5. So the slope of line B is -4/5. Now this has a rise of -4, run of +5, or it could have a rise of +4 and a run of -5. And the negative can go either on the rise or the run. B. What is the slope of line D? In line D, locating line D, we see it's this one right here. We do have 2 points on it, but before we look at the slope formula, notice this line is a vertical line. It stays on the same x value all the way through. Since it's vertical, from your notes you know that all vertical lines are in the form of x equal a, where a is the x-intercept. Well, a here, crossing the x-axis, is at 4. There's 0, 1, 2, 3, 4. So there's the a, which is 4. So therefore, the equation of this line would be x equal 4. But the point is, the slope of vertical lines is, they're always undefined. So slope is undefined. Now, if you ever forget that, what you can do is take 2 points on that line anyway. Let's take those 2. Let's let 4, 0 be our first point. So this will be x1 and 0 be y1. And the other point right here at 4, -2, let's let 4 be x2, y be y2 equal -2. Using the slope formula for line D, the difference in the y's would be 0 minus -2 over, and then the difference in the x's, that would be 4 minus 4. That gives us 0 minus -2 is 2, and 4 minus 4 is 0. And as you know from past years in mathematics, that division by 0 is impossible, and it means that it's undefined, so that means the slope has to be undefined. Part C, what is the slope of line A? See if you can find the slope of line A. Turn off or pause the video, and then we'll check it. Okay, what is the slope of line A? Part C, here's line A, and there's 2 points provided on that line, one here and one here. I'm going to let this be my first point, so x1, y1, and this one be my second point, x2, y2. Using the slope formula, the slope of line A is y2 minus y1, or the difference in the y coordinates, 7 minus 3. over the difference in the x-coordinates back over here to 5 minus 2. 7 minus 3 is 4. 5 minus 2 is 3. So the slope of line A is 4/3, or 4 to 3. The rise over the run. Example 2. In example 2, you'll graph lines using the y-intercept and slope of the line's equation. Now, when using slope and y-intercept to graph a line, you must at some point use the equation in slope-intercept form. So, starting with example 2 here, graph the lines given each equation. A, what is the graph of y equal 1/4 x minus 2? Well, if we use slope-intercept form, we'll notice this is already in that form, y equal mx plus b, where m is the coefficient of x. Does not include the x. Don't include the x in the slope. It's the coefficient of x, so it'd be 1 to 4, or 1/4. And b, which is the y-intercept, would be -2 because this is plus -2. B is 2, -2. Then, if you'll recall from your graphing methods from last year, you start with the y-intercept. You start at the origin and go to that point on the y-axis. That's -2. So right here, there's one of my points on the line. And then from that point, we use the slope. This is rise over run. The rise is 1 unit, so we go up 1 unit. And the run is positive 4 units, so we go to the right 4 units. 1, 2, 3, 4. And there's another point on our line. Now, another way you can do this is use -1 over -4, because -1 divided by -4 is still positive 1/4. This is another way you can use rise or run. You start here and go down 1. Then you can go left 4. 1, 2, 3, 4. And notice you're going to get the same line when you draw it. Take a straight edge. Make sure you clear the entire coordinate grid or plane. Not just part of it. Don't go from dot to dot, so to speak. Go through the whole thing. Line it up very carefully. And you graph. And of course, line goes on forever. Normally, we label the line with the equation, the original equation. So y equal 1/4 x minus 2. Part B, what is the graph of y plus 2 equals -3 times x plus 1? This time, this equation is not in slope-intercept form, so we need to get it into that form, and then we can use the same method we did here. So we've got y plus 2 equal -3 times x plus 1. Using the distributive property here, we have y plus 2 equals -3x minus 3. Then getting y by itself so that we have it in y equal mx plus b form. We subtract 2 from both sides, and we get y equals -3x minus 5. So there's our equation in slope-intercept form, where m is -3, or -3 over 1, or 3 over -1. We can put the negative down there if we want. And the y-intercept is at -5. So starting with the y-intercept, we go down to -5 from the origin. 1, 2, 3, 4, 5. There's one of our points. From that point, we use the slope. I'll use both of them. -3 to 1. -3 is the rise, which means I would go down 3. 1, 2, 3. But then I would go positive 1 in the run direction to the right. Or, using this one, 3 over -1, I'd start at that y-intercept, and I would go or go up 3, because the rise would be positive 3, 1, 2, 3, and go to the left 1. Take a straight edge, a ruler, line those up very carefully, clear the entire coordinate grid. To line and label the equation, or the line with the equation. Y plus 2 equals -3 times x plus 1. Notice this has negative slope. and it should because it's falling. This one up here had positive slope, and it should because it's rising. Example 3. In this example, you'll learn to write the equation of a line based on limited information given about the line to write the line's equation in slope-intercept form. A. What is the equation for a line in slope-intercept form with slope 3 and the y-intercept of -5? This one's pretty straightforward. We've got the slope and we've got the y-intercept directly. Slope is 3. Y-intercept B is -5. As long as we have the slope and the y-intercept, we can directly use the slope-intercept form of a line, y equal mx plus b. So substituting in these values and then simplifying, we get y equal m, which is 3 times x, plus b, which is -5. And then just simplify it a little bit here, no double signs, and we get y equal 3x minus 5. So this is the equation of the line that they're describing here. Part B. What is the equation for the line in slope-intercept form that goes through the point -1, 5 and has slope 2? Well, we've got our slope, it's 2. But we don't directly have our y-intercept. So what we can do is use the point-slope form of a line that we went over on our notes, which is y minus y1 equal m times x minus x1. Anytime you're given at least one point and the slope, you can use the point-slope form. Point slope, point slope. And so x1 and y1 are used for the point that you're given. So that means this one here and this one here are going to be replaced. This x and this y are part of the general equation. So we have the slope is 2, so we start substituting in. This is y minus y1, which is our point, the y-coordinate 5, equal the slope 2 times x minus x1 is -1. Then we simplify. We get y minus 5 equals 2 times x plus 1. We get y minus 5 equal, using the distributive property, 2x plus 2. Putting it in slope-intercept form, we add 5 to both sides. And y is equal to 2x plus 7. Y equal 2x plus 7 is the equation of the line represented by this information. From this point, you could go ahead and graph them if you would like to or wanted to. Example 4. In example 4, you learn to write the equation of a line given the graph of that line. Now be careful with graphs of lines. Many times we can approximate or estimate the equation of a line just looking at it, but many times, and if you want to make sure it's accurate, you need to use your mathematical skills that you've learned about writing equations of lines. For instance, notice here that B, the y-intercept, is not clear. It looks like it's halfway between, what, 1 and 2 on the y-axis, but we don't know that for sure. So B is unclear. And that's just one of many reasons why you want to stick with the mathematics of finding the equation of the line. Now we do have 2 points on the line, so write the equation of the line at the right. Start with, we've got 2 points. Go ahead and write those down. -2, -1. And the other point on the line is at 3, 5. Anytime you're given at least 2 points on a line, you can always find the slope of that line. So we can find the slope using these two. The slope of this line, y2 minus y1 over x2 minus x1, I'll let this be my first point, x1, y1, and this be my second point, x2, y2. So using the slope formula, we have y2, which is 5, minus y1, which is -1, over, back over to x2, which is 3, minus x1, which is -2. This gives us 5 plus 1 over 3 plus 2, and this gives us 6 over 5. So the slope of this line is at 6 to 5, or 6/5. Rise is 6, run is 5. Then for the y-intercept, we're going to have to find that kind of by default here. We've got the slope, and we've got at least one point, so we can use point slope form. Which again is y minus y1 equal m times x minus x1. And we've got to use one of these 2 points. It doesn't really matter which one you use. You can use either one and you're going to end up with the same equation regardless of which way you do it. I'm going to go ahead and use the first point here, the one with the 2 negatives in it. It's already have them labeled. So I'm going to use the slope and this point right here, point slope, and I've got y minus y1, which is -1, equal slope, which is 6/5, times x minus x1, which is -2. Now, in a way, it was good we used the negatives because everything's going to be positive here now. But anyway, y minus -1 is y plus 1 equal 6/5 times x plus 2. Now, we have to use the distributive property here. We have y plus 1 equals 6/5 x plus 6/5 times 2. Well, 6/5 times 2, there's no numbers we can divide out or simplify, so we're stuck with multiplying the numerators and denominators. So when we get to it, this will be 6 times 2, this will be 5 times 1. So now we have y plus 1 equals 6/5 x plus 6 times 2 is 12, 5 times 1 is 5. And we still need to get rid of this 1 to put it in slope intercept form. So subtract 1 from both sides. On this side we get y equals 6/5 x plus these 2 numbers here. When you add or subtract fractions, don't forget you have to find the least common denominator. If I'm subtracting 1 whole, I need it to be in fifths. So I write 1 whole in fifths. That would be 5/5. 12 minus 5 is 7/5. And so this is the equation of the line. And notice this was not halfway. If it had been halfway, it would have been, let's see, 1, 2, 3 halves. And this is not 3 halves, it's 7/5. So it's a good thing we did it this way and we didn't just assume that was halfway between there and there. Anyway, here's the equation of the line. Example 5. In this example, you'll learn to write the equation of a line given the graph of that line. You're going to learn how to write the equations of 2 lines that are horizontal and vertical. That's that first part. What are the equations of the horizontal and vertical lines through the point 2, 4? Graph each line. What is the slope of each? Now, when working with horizontal and vertical lines, using slope intercept or point slope forms, they don't really help you. You must know the information about vertical and horizontal lines to help you out. So either you need to memorize it or you need to work with it enough that you remember it. So let's discuss this one. They want us to find the equations of the lines, they want us to graph them, they want us to find their slopes. So let's go graph the point first. 2, 4. Start at the origin, go to the right 2, up 4. 1, 2, 3, 4. So there's 2, 4. Okay, we've got our point and we want to draw a horizontal line and a vertical line that have that point in common. So starting with the horizontal line, if you recall, the form for horizontal line is y equals the y-intercept b. So you're looking at a horizontal line that has to go through this point. It's got to be a line that goes along this grid right here. Well, if you move your position over to the y-axis, obviously the y coordinate here, or the y-intercept, is 4. So this is b right here, 4. So y equals 4 is our equation. Okay, and then the slope of that, what is the slope of any horizontal line? 0. For a vertical line, Recall that the equation of the form of the equation of that line is x equal the x-intercept, which we refer to as a. And so if it has to go through this point, it's got to be vertical, which means it has to cross the x-axis right here. So the x-intercept would be at 2, a equal 2. This was b equal 4. So the equation of our line is x equal 2, the a or x coordinate here. And the slope of any vertical line, no matter what number is here, it has to be undefined. So undefined slope. To graph them, use a straight edge, completely go clear across the graph. I'm going to do the vertical one first. Make sure it's vertical, go clear across, it's a line, and label the equation, or the line with the equation. So this is x equal 2, and then the horizontal goes this way, and this is y equal 4. There you have it. Example 6. In example 6, this one, you're going to learn how to check to see if 3 points are actually on the same line. So, and we're going to have to do a little verification here. Without using a graph, determine if the 3 given points are collinear, all on the same line. Justify your answer. And we've got these 3 points. Now, they said without using a graph. Obviously, a simple way to do this would be to graph those 3 and line them up with a straight edge, but we want to look at this more analytically. So what we can do, and we'll be smart about this, is if we find the slope using 2 of these, that means both these points would have to be on that line. Agree? Well, once we find the slope of those 2, all we have is one more point left to check to see if it's on the line. And probably the quickest way to do this is just to take one of the points you've already used and that third one to see if that slope is exactly the same. And if it is, all 3 of those will be on the same line, therefore collinear. So we want to check to see if the slope of, let's see, I think I called this one A, B, and C. Slope of AB is equal to the slope of BC. And you could do it another way. There's several ways you can do this. This is probably the fastest. Alright, the formula for the slope, of course, again is y2 minus y1 over x2 minus x1. Well, so we need to assign some values here. I'm going to let A be a first point. That would be x1 and y1. And B be my second point, x2, y2. Well, eventually I'm going to use BC, and I've already got these labeled with 2, so I'm going to let this be another first point, x1, y1. So let's start with these 2 first. The slope of AB, I'm going to go ahead and use one equation here. Just keep working down. The slope of AB, that would be the quotient. We have on the top, we have y2 minus y1, so that's 3 minus negative 4 over 2 minus 5 equals, hopefully it'll equal the slope of BC, these 2. Well, y2 is 3 this time, again, minus y1 this time is 10 over, and then back over here, x2 is 2 minus x1 is negative 1. Let's see if those equal each other. 3 minus negative 4 is 3 plus 4. 2 minus 5 is negative 3. Let's see if that equals 3 minus 10, which is negative 7. 2 minus negative 1 is 2 plus 1. 3 plus 4 is 7 over negative 3. Negative 7 over 2 plus 1 is 3. Now, are those the same? Yes, they are. There's one negative sign or symbol on both 7/3, so it's both of them are equal to 7/3. So this is our verification. Therefore, the points are collinear.